Hi there and welcome everybody, and thank you for joining us for today's APMG webinar in partnership with the Big Data Framework. My name's Estelle Hicks-Bennett and I'll be your host and moderator today. I'm delighted to be joined by Jan-Willem Middelburg, founder of the Big Data Framework and author of several books, including the Enterprise Big Data Framework Guidance Series. Jan-Willem's a pioneer and advocate for professionalisation in automation and big data, and when not in lockdown can frequently be found delivering keynote speeches or moderating at universities and technology conferences around the world. Before I hand over to Jan-Willem and he takes us on a deep dive into classification, algorithms and big data analysis, here's a little housekeeping for you. We are recording this webinar and we will be sending you the slides and recording via email afterwards. You can enter questions in your question panel, as you can see on the slide here. So please do send those throughout and we'll get to those at the end of the webinar. Your feedback is very important to us and we welcome it, good or bad. Please do let us know what you thought of the content and anything more that you'd like to hear from us. Please note we are still working from home, so if you do experience any kind of interruptions, please let us know in the chat so that we can try and make sure that you get the full experience here. So great to have you all with us today, and over to you, Jan-Willem. Thank you very much.
Thank you so much, Estelle, for the kind introduction as always, and I'm very happy to be here today and give this lecture more on the classification algorithms. What we're going to do today is do a little bit more of a deep dive. So we're actually going beyond some of the more introductory topics of that we discussed in some of the webinars that we did previously. So what I'm trying to showcase today is going to be a bit of an overview of what you can actually do with big data analysis. And we're going to look at some of the most commonly used machine learning algorithms, and especially in classification, in order to do that. The purpose of this webinar for that reason is to inspire you to become active into the domain of data science and to become a big data analyst. And the way that I want to show that today is also by showing some real life examples. So in the first part of this webinar, I'm just going to give you a bit of background about what data analysis actually is, what are some of the common best practices that are related to it, and we will look at some of the theories behind classification and common classification algorithms. Obviously, this is a topic that we can spend days filling to talk about. So what I've done for this particular webinar is that I have made a selection from some of the most popular classification algorithms. And I will showcase how they work. So I'm going to give a bit of a deep dive into the more technical nature of one of these algorithms. But I always think that seeing is believing. So in the second part of this webinar, we're going to go into a more interactive lab. So for today's session, I've prepared a lab with which you can follow along and actually practice some of the things that I've been doing. Don't worry, you don't need to be any educated data scientist in order to follow along. I've made it in such a way that it's very easy to follow, and especially if you have learned a little bit about the analysis processes and classification algorithms, you will see the step-by-step execution. And you can actually see how we can apply some of these things in practice in order to solve real enterprise problems. So that's a bit of the agenda for today. We have a lot to cover today, so I'm just going to get started with explaining some of the basic elements around data analysis and the big data framework. Before I kick off with the deep dive into classification, let me just do a very short recap of the Enterprise Big Data Framework and the key components towards the framework itself. Because in this webinar, we kind of build upon some of the knowledge that we've discussed in some of our previous sessions. So it's good to always be able to put things into the bigger picture. On the slide in front of you, you see the 6 core capabilities that are part of the Enterprise Big Data Framework. And as a bit of a recap, the Enterprise Big Data Framework really focuses on the key capabilities that organizations need to have in place in order to extract real value from data sets. And especially in large companies, there are a variety of different data sets. There's a lot of different things that could potentially be analyzed. So for that reason, it's very advisable to set up a framework right from the start so that you have different capabilities that you can build over time. So the 6 core capabilities are depicted here on the slide, and it all starts with strategy. You need to think about architectures, the way you're going to look at algorithms, processes like data privacy and security processes, the human element, which is depicted in the big data functions aspect, and the artificial intelligence, which is kind of the algorithms that complete it and that look at mimicking human decision making on data in the enterprise. So today, unfortunately, we're not going to be able to cover that full framework in full force, but it's good to know what we're specifically focusing on. As you might be familiar when you signed up for this webinar today, this is part of the Enterprise Big Data Framework series, and today's materials and content are focused more toward the Enterprise Big Data Analyst level. So the content from this webinar and some of the examples I'll be showcasing are coming from the Enterprise Big Data Analyst level. So after this course, I'm very sure that Estelle will send you a follow-up email with the correct links to all of the materials. You can download all of the books for free, so you can just get started and keep continuing your journey into Enterprise Big Data if you're interested to do so. And hopefully after this session today, I will have inspired you to set these next couple of steps. Good. Today, we're going to take a bit of a deeper dive into data analysis. And one specific area that we're going to focus on is classification and classification algorithms. And this builds upon the knowledge about data analysis, which is not something which is a completely new field. It has been around for quite a long time. And I always think in order to kind of understand where we are today is that it's good to place things a little bit into historic perspective. So we look where data analysis is coming from, and that, of course, is the prerequisite for modern day approaches like data science, the data analysis, and all of the new fancy titles that have come along in the last decades, is that we're really focusing on the procedures to analyze data, the techniques for interpreting data results, and especially on the procedures. And that's exactly what I'm going to be covering today. I'm going to look at a number of these key procedures and what is the knowledge that you would need in order to become a good data analyst. Because this is nowadays a full-fledged profession. It is something that adds a lot of value to enterprises and in which you can highly specialize and become an invaluable asset to any organization. Good. So as we've seen in the previous slide, the data analysis in itself is nothing new. Basically, it builds upon the knowledge from statistics, which is a field that's even older than the 1960s. So data analysis is the process. It is the process of extracting value from big data sets. So what we will do in the big data analyst course and the materials is that we will focus on this process. Because no matter which enterprise problem you're trying to solve, there are a number of steps that you need to go through in order to make it sound analysis. And this has a lot to do with the way that you dive into your data, the decisions that you make in order to clean up your data, and then eventually the way that you build your model. And the most important part of that entire journey of data analysis is that you take the right steps. It is that you make steps that are explainable to other people so that they can follow the steps that you are taking and that they can follow the research along. So in that sense, it's a highly process-oriented profession. And this is sometimes something I think a lot of people forget, because data analysis is not just about running a particular algorithm. It is the whole process, all the way from defining your business objectives right at the start towards visualizing your data, producing good reports, and showcasing decisions that can be backed up by that data. And as you can see at the bottom of this slide, this is basically an iterative process. And what we do in big data analysis is that we move from defining that enterprise big data business objective towards the data presentation. And if I enlarge this picture a little bit more in further detail, you can basically see that data analysis is a process that consists of 5 main steps. we start with looking at the objective of a particular company. And this is really all the way at the start. What is the value that we want to get? What is the question that we would like to get answered? How can we make certain predictions? All of this is the first stage of data analysis, understanding the question, understanding what you need to answer in order to move forward. Then you will need to move through the process of what we're referring to as the data pipeline. And that basically consists of ingesting the data from different sources. And those sources could be data that you currently have in your organization, or it could be data that is from external sources, such as social media or research divisions. And that data first needs to be ingested into the organization. After you have that data present, you also need to look at the data source that you have. And typically that involves a process of cleaning up the data and making sure that you put it into a format that you can analyze subsequently. And that whole process is known as data preparation, which is the second step and which you see in the middle of the slide. After you have that cleaned up data set and you know the data that you're going to be analyzing, then we move towards data analysis itself. And that's going to be the key focus point for today. Within data analysis, depending on the business objective that you've described all the way at the front, there are a couple of key models that you can use and a number of analysis techniques. Things like inference, regression, classification, clustering, and outlier detection, as you can see here on the screen. And of course, this whole process all ends in data presentation, because not everybody in the world is a data analyst or a data scientist. So you need to be able to convert your research and your data into something that people can understand, into good reports, visualizations, and frequently in interactive dashboards. So as you can see, the whole big data analysis process is quite comprehensive. There's a lot of different things that we can cover and a lot of different focus areas. However, in this overview of the big data overview of classification, of course, we don't have the time to analyze and discuss all of these different topics. So what I've done for this webinar today is that I have focused on one of the topics within analysis, and that is going to be about classification. So in this slide, you can kind of see the bigger picture in terms of what is going to be the focus area that we're going to look into. So this is where I'm going to zoom into and that we will discuss in the rest of this session. Good. Classification is basically a form that is known as machine learning. And we're going to be looking at a number of machine learning algorithms in this particular session. Over the years, the domains of big data and machine learning have become more closely interwoven, because the data sets in organizations get larger and larger, and there's also more valuable data sources available, such as, for instance, the social media data that I've just showcased. What we're trying to do within machine learning is look at the study and construction of algorithms that can learn and make predictions from data, so that as soon as I have a data set, I am able, without ever having seen new incoming data, to make a right kind of prediction. And as you can imagine, that could be very, very valuable for organizations. Because, for example, think about if you have new customers coming, for instance, to purchase a credit card or take a loan for a house, then you would like to have a good algorithm that can predict whether that is going to be a good customer for the bank or somebody that you might run into problems with along the way. So these kinds of predictive algorithms are very important from a business point of view. And you can immediately see that if you do that a couple of percentages better than your competitors, then you're going to have this massive competitive advantage. So what we're trying to do within the whole domain of machine learning is try to teach our computers how they can make better decisions towards the future. And that is exactly what I will showcase in the lab a little bit later. How can we learn a computer to make the right kind of prediction towards the future? And as we will see in the examples that will follow in the second part of this webinar, you are actually able to make very, very accurate predictions with these types of machine learning algorithms. So that's the objective. With these machine learning algorithms, we're going to look at data sets, and we're going to use predictive technologies to find unknown or hidden patterns into large sections of data. If we look at the overall domain of machine learning and machine learning algorithms, you can see that we can subdivide it into a number of different elements that I've also shown in the previous slide about the big data analysis process. So again, because of scoping reasons for a webinar today, what I'm going to focus on today is on classification. And classification really is a form of supervised learning that looks at discrete data in order to make predictions towards the future. So if those terms don't mean anything to you right now, don't worry, I'm going to explain all of them in the next couple of slides. Let me start with giving you an overview of what supervised machine learning is, because that is going to be very crucial in order to understand classification. What we're trying to do in supervised machine learning is that based on a data set that comes into our organization, we're going to build a model based on the data that we already have, because we need to learn, we need to train the machine in order to make these kinds of decisions. And a very good analogy of supervised learning is always the way that you parent and that you educate your own kids. If you have kids, you know that you will need to learn them about wrong or right behavior. And then hopefully the next time that your child encounters a similar situation, based upon what it has learned in the past, it can make better decisions, or it will execute the teachings that you hopefully have learned previously. So this is why we call parenting supervision. This is why we call supervised machine learning supervision. We're actually actively teaching a machine how to make wrong and right decisions, so that next time that they encounter a similar situation, they can make a better decision. So what we first will need to do in supervised machine learning, and you will also see this a little bit later when we talk about our example of classification, is that we will need to learn the machine what kind of decisions it would need to make. And after we've done that, then hopefully the next time it will be able to make decisions by itself. So if we zoom in a little bit on the picture that I showcased on the right, here you see the basic process. On the left-hand side, data comes into your organization. And what we're going to be doing is that we're going to be looking at that data in order to see if there's a particular pattern. And based upon that pattern, we can start to design our model. We can design our algorithm. And based on those previous observations, we can start classification processes. In the example that I gave earlier, suppose that somebody comes into a bank asking for a loan. Then based on all the previous loan applicants that the bank has already processed, and whether they were successful loans or that the people defaulted, we are able to classify into different directions. So that data has a tremendous wealth of information. And based upon that, we can make a prediction whether a person is likely to pay back his loan over time, or whether that same person is going to default. And that's the algorithm that is exactly used if you go out for a mortgage or you request a credit card. This is the algorithm that banks use in order to give you a particular amount of money or not. So that's the basic idea of supervised machine learning. And this is something that we're going to illustrate a little bit later in the real example. Good. Why is this important? Well, it's really important to kind of compare that with the other form of machine learning, which is unsupervised. And with unsupervised machine learning, we are going to showcase a machine new data, and then it needs to make decisions all by itself. So we don't actively teach the machine something. Today, we won't be going into a lot of depth about unsupervised machine learning, because that's not going to be within the domain of classification, but it's good to know that these two differences exist. So unsupervised machine learning is really a form of machine learning where we don't actively train a computer to do something. So if you compare this particular picture to the one that I've showcased to you earlier, you can see that there's no human involvement. In unsupervised machine learning, it is just a computer that will execute a number of workflows automatically based on the input data. So it's good to know the difference between the two so that you can make an adequate comparison, as we will see a little bit later. Good. So the key point that I want to make is that when we're going to look at classification, we're going to be talking about supervised machine learning. So what is classification then exactly? Classification is the process of assigning a particular class or category towards an unknown data point. So for instance, think back about a very common example. If you upload a photo to Facebook, then that Facebook is going to give you a suggestion which person is in that photograph. Basically, out of all of your friends that you are connected with in your Facebook account, it is going to assign a particular person towards that photo based on the likeliness in their face and the dimensions of the particular photograph. It's going to look at assigning a particular name towards that photograph because it predicts who is going to be in that photograph. And if you're a Facebook user, you will know that this is fairly accurate and highly accurate in some cases. Basically, what is happening here behind the scenes is that a classification algorithm is applied. We're assigning a class to an unknown data set. So in this case, we have a photograph, we don't know anything about it, we're analyzing it, and based upon all of the previous photographs that are on the Facebook platform, it is going to assign a class, in this case a name, towards the photograph. So that's the essence of classification. Another very common example of classification in a more simplistic version is the classification of the messages that you receive in your email box. So in your email box, no matter whether you're using Outlook or any other kind of application, you always have an email box with your regular messages and an email box with your spam. And those are two different folders. So every time a new email comes in, your computer needs to make a decision whether it's going to give the label normal message towards the email, or it's going to assign the label spam. So in this case, we're talking about binary classification because it needs to just decide between two different objectives or two different labels. Obviously, this is again a classification exercise. So I hope that by now you're starting to get the main point. And the main point is in classification, we assign a particular class towards an unknown observation or something we've never seen before based on our history, so based on historic data. And if you do that well, you can see that this can be done in a fairly accurate way. The next question now, of course, is, well, now that I know something about classification and I know what the key objective is, how do we actually do that? Because in order to run a particular algorithm, which we typically in classification refer to as a classifier, we need to have a particular methodology in order to do that. And that's what we're going to look at next. Let me first start with saying that there are dozens of classification algorithms that exist. Some of them are used for very specific situations. So in the examples that I've used earlier, you can kind of imagine that a classification algorithm that is used in order to identify names towards pictures is a different type of algorithm than the one that would be used in order to classify your spam messages in your emails. So there's a variety of different classification algorithms. So in order to become a good data analyst or a data scientist, it's first of all very important that you can kind of know what are the major topics and what are the major classification algorithms, and especially how do I use a particular algorithm into a particular situation. So in the data analyst course and the materials, basically we give an overview of 4 common algorithms that are used as classification algorithms. Each of these will work best given a particular data set. So for now and for the explanation today, we won't go into all of them in more detail, but I would like to make the point that there are multiple classification algorithms that exist. So the one that we're going to use today is called the K-Nearest Neighbor Classification algorithm. And what I will do next is I will give you a bit of an insight first of how this classification algorithm works, and then we're going to see it in practice. You should, however, realize that this is not the only classification algorithm and that there are a variety of other ones. So other very popular ones are naive-Bayes, logistic regression, or classification trees. Maybe if Estelle is kind enough, she will invite me on the next webinar and I can talk about some of these other classification algorithms. Good.
Of course.
I was hoping you would react to that. What we're going to do is look at one particular classification algorithm, and that's also what I've prepared the lab about. This classification algorithm is called K-Nearest Neighbors, and this is basically one of the most basic and frequently used algorithms for classification purposes. So I'll give you a brief overview of how it works. I promise you I won't go into the too technical nature, but it's good to have at least some familiarity of what it does. The K-Nearest Neighbor algorithm is a non-parametric approach, which means that you're going to try in a number of sequences to find the optimal solution. The K in K-Nearest Neighbors stands for the number of nearest neighbors that we're going to consider. And I will explain that into the next slide into further detail. But this is something that you would need to decide as the data analyst. What is the optimal value of K and how can I find the most accurate model if I'm using this particular algorithm? So in order to kind of understand how it works, we're going to have a look at K-Nearest Neighbor from a more mathematical point of view. And again, don't worry, this is all although it looks very complex, this is all very simple. The K-Nearest Neighbor algorithm is namely based on distance. And you can see the formula with which we are calculating distance below. And the reason that I'm illustrating this particular algorithm is that because of its simplicity. The formula might look pretty scary downstairs, but this is nothing else than the Pythagorean triangle that every one of us has learned in high school. A squared is b squared plus c squared. So if we want to know the distance in a two-dimensional plane anywhere, we are able to calculate the distance between those by looking at the x-axis and the y-axis. So this is a very, very simple algorithmic algorithm that is just looking at the distance. And the way that I've always explained it is as follows. If you are living in an apartment building or you're living in a house, and I would ask you, who are your 5 nearest neighbors? Then automatically, you're going to have an idea of who that are. First of all, it's probably the person that lives right in the house right to you and the person that lives in the building left to you. You will immediately consider those your neighbors. But remember that I asked you who are your 5 nearest neighbors. So now it becomes a little bit more complex because, for instance, if you're living in an apartment building, your other nearest neighbors are the person on top of you or the person below you if you're at a higher floor. But if you're living in a house on a lane, for instance, that might be the person that lives across the street from you. So ask yourself, how do you make that decision? The most probable way in which you're going to answer the question who your nearest neighbors in your own vicinity are is by, in your mind, calculating some form of distance. Because if the neighbor across to you is a highway in between you, you will probably not, or there's a park in between you, you will probably not say that that is your nearest neighbor, and you will pick, for instance, your neighbors who are 2 doors down the road. So this is exactly the same. This is exactly the way how the K-Nearest Neighbor algorithm works. it will look at your nearest neighbors based on distance. Very similar to the example I've just provided. So in order to illustrate this, and this is a very simple example, we can look at the following situation. For example, suppose that we would need to assign a class, in this case a color, towards the data point in green. What would be your answer to that question? Well, first of all, you would need to know how many neighbors would I need to consider. So in this case, I have given you the fact that we need to look at the 3 closest neighbors. So the way that it works here is, of course, very simple. I will first need to take a look at the 3 nearest neighbors towards the green data point. And if I look at that, I will see that there is 2 points that are in blue, and there's 1 point that is in purple. So very naturally, you would be inclined to say, well, if this is the case and I need to consider the 3 nearest neighbors, I am going to classify this particular point as blue. And congratulations, because that means that you kind of understand how K-Nearest Neighbor works. It's exactly the same, even if you're using thousands of points or millions of data points. The algorithm works in the exact same way. So you might then ask the question, well, why is it then important to do this? How will the algorithm do that? So basically, the algorithm will execute that based on a number of steps. You can see that here in the next slide. So in this case, we have different colors, but also different shapes. So for instance, if you look at the point here that is reflected by the question mark, the question is, will we classify this as a star, or will we classify this as a triangle, or red or green? So what the algorithm will do is that it will calculate the distance towards its closest neighbors. And in the second picture, you see that here, for instance, we're considering the 6 closest neighbors. So here we're running into a problem, because should we then assign it to red, or should we assign it to green? And the answer, of course, would be, well, whichever the distance towards green or red is closer. So the algorithm, based on the Pythagorean's triangle, or which we refer to as the Euclidean distance, will calculate the distance, or the sum of distances towards the red points and the sum of distances towards the green points. So that's important, because then we are able to classify it accordingly. So again, very similar to the previous slide, if K would be 3, we would classify it as a green point, because the 2 green elements are the closest to the data points that we're expecting. So that, of course, is interesting. And you might say, well, that's all very nice and well, but why is then the value of K so interesting? Because would we not always classify a data point towards the closest neighbors? And the answer is yes, you will be correct. But look at the next slide here, and how these differ if you set different values of K. Let me illustrate this in the following way. Suppose that we're saying that K is 3. Then we would be looking at the 3 closest neighbors. So we can see that there's 1 in red, and there are 2 triangles in green. So naturally, you would be inclined to label this unknown observation as green. But now look at the same situation, and I would say that instead of considering the 3 closest neighbors, I'm going to consider the 7 closest neighbors. If we do that, we will start counting, and you will see the second circle around it. In this case, we would have 3 data points which are in green, but now we have 4 which would be red stars, and the algorithm would classify this data point as a red star. So the reason I'm showing you this is that as a data analyst, it's up to you to make the decision which K we're going to select. There are a number of different techniques to select the optimal value of K. And this is what you need to understand in order to work further in data analysis. Good, so hopefully by now I have kind of convinced you of how this classification algorithm works and what it is aiming to solve. So what is the problem that it's aiming to solve? So although the previous slides were all in a two-dimensional pane and we just consider two different variables, I hope that you can kind of see that this same algorithm can be used with thousands of rows or hundreds of different variables, because the basic idea doesn't change. We're looking at the number of neighbors that are closest, and we're then going to assign the class of the nearest neighbors. That's in essence how the algorithm works, and that is in essence how simple it actually is. Good. I know that this might be a lot of new information, especially if you're new to this particular field. So therefore, I thought it would be good to, in this webinar today, also kind of showcase a real-life experiment. And you can try to follow along with this experiment. What we're going to do next is that we're going to be looking at the KNN classification algorithm in the Python language. And Python is just a data science language, which is one of the two most commonly used ones. So for that, we're going to use a bit of a shortcut because we're going to use the algorithm that has already been pre-programmed within the sklearn package. And then I'm going to import this particular classifier so that we can very easily use that. Again, don't worry if you don't understand the Python code, that's all perfectly fine. The key point for today is to make you familiar with what are the key things that you would need to know as a data analyst, and what would be the steps that you would need to take in order to get there. So let me explain that with the following case study. This is a real-life case study, so we're going to look at applying the KNN algorithm towards a particular context in an enterprise, because remember, this is the enterprise big data framework, so we're looking to solve business problems. And in this case study, we're going to look at a property management company. And in this case, this is a property management company that manages around 150,000 buildings around the world. So it has quite a lot of data. So one of the problems that a property management company has is whether the units that they're managing, whether they're occupied or not. And especially if there's no formal rental agreement in place, if somebody is not actually using that particular property. So the question that we're going to try to answer with this classification problem is it possible that if I know different sensory data about a particular unit, so a particular property that they're managing, can we make an adequate prediction on whether somebody's actually living in that unit or whether it is unoccupied? And this is what we're going to look at. So the way that I've prepared the lab for today is that we're going to look at, first of all, we're going to look at a training set. This is how we're going to train our model. I've all prepared this already for you within the environment, so this is just, you just have to believe me that the data is there and that it's coming from this particular company. So we'll consider around 8,000 different units, and what we will do first, and this is what I'm going to do in the lab, is I will show you how to use that in order to make predictions upon unknown data. So for instance, if I just give you a particular unit somewhere in the world and I give you a couple of key readings, like for instance, the temperature or the CO2 in that particular unit, could you make a classification to say with a certain amount of accuracy, is somebody living in that unit, yes or no? What I've also done is that I have prepared a second test set with which you can practice yourself after this webinar today. So I've asked a couple of questions and you can answer those by yourself after the webinar today. So within the data, we just are going to look at a number of very simple variables. It is, for instance, the temperature, the humidity in the unit, the light, the CO2, the humidity ratio, the relative humidity, and the key thing that we're interested in is, of course, is that unit occupied or not? So we're going to assign a 0 if it's not occupied, or we're going to assign a 1 if it's occupied. So this is a very simple problem that we're going to try to solve with the K-Nearest Neighbor algorithm. So let me switch my screen real quickly so that we can move towards a browser-based version of Python. Good, I think the screen has switched. Yes, it has. So what I've prepared for everyone in the webinar today is basically a lab. And this is part, of course, of the Enterprise Big Data and Analyst course. So what we're doing in this particular lab is, now that you have learned a little bit about what the K-Nearest Neighbor algorithm does, we're now going to see how it would work in practice. So in this particular aspect, we're going to just run through the KNN model, which is a subsection that I've prepared for today. This lab, and Estelle will share the link with you afterwards, is available online, and I've made it open for the next 2 weeks. So you can download this particular file, and if you sign in with your Google account, you can also just make a copy of this file and play with it around with yourself. So the thing that we're going to do first is that we are going to import a number of the packages that I've showcased earlier. This basically imports into Python a number of libraries so that we can execute the KNN algorithm. It's basically a plugin. It's something which provides extra functionality towards this Python environment so that you can get started all by yourself. The next thing that we would need to do is that we would need to upload our data. So the data sources that we're actually going to analyze, this is something that we would need to analyze. What I've done already is I've made a quick uploader, so you can very easily upload files by just choosing the file and selecting it from your computer. This means that you don't need to use anything complicated in order to get the files analyzed. Before this webinar started, I have already done that. So here on the left, you will see that I already have the availability of a training set. I have a test set, and I've also uploaded the data test set too for yourself afterwards. So what I will do next is that I will start to read in these data sets because I need to have them all at one centralized place. So I'm just going to, in these 3 lines, going to read in the data set in more detail. And then what I will do is that I will open up our training data set into a pandas data frame. That doesn't mean anything to you today. Don't worry about it. These are key elements that you will learn in the data analyst course. Next, what I will do is that I will print out the first couple of rows of my data sets. So if I do that, you will see that the algorithm will run in the back end. Right, requires some time because it has not been connected to the internet for a while. So the algorithm is running here in the back end, and it's trying to make sure that it actually runs. So while it does that in the back end, let me go and explain the next step, which we see right over here. The next thing that I will do is that what we're going to try to do is, based on that training set, I'm going to train my model. So what I will do next is we first need to train the model. And this is frequently referred to as fitting the data to the model. And this is exactly what we're doing and what I've showcased in the slides previously. Based upon that, I will have my algorithm in place. And then next time a new observation or an unknown data point comes in, we can predict what happens with that different data point. So this is exactly what we're going to do in the next step. So in order to run and follow along in this algorithm or in this webinar, after you've opened up the browser, the only thing that you need to do is just click all the play buttons and it will do everything automatically for you. So here you can see from the output that our model has been built and it has done that automatically. One of the key points I also wanted to make here is that you have seen that it executed this within split seconds, even though it's running through 8,000 different rows with different variables, and it's going to calculate the distances between all of those different data sets. And this is exactly why we're using Python or the R programming language, because it greatly speeds up our analysis. We can do this way quicker than we could ever do it in Excel. So based upon that, we're going to look at whether we could say something about our training set. So remember that there are 5 key variables that we would like to analyze in order to predict whether a particular apartment is actually occupied. So we're going to only look at the temperature, the humidity, the light, the CO2, and the humidity ratio, and whether it's possible to make a prediction based upon that. Our target variable in this case is the occupancy column, which is, can it predict whether a unit is occupied or not? So what we will do is that we're next going to test the model, and that is why I've provided you also with this test training set. So what you need to do is upload it, which I've already done, and then we're going to need to save that into a data frame again. So in our test set, we have around 2,600 observations, and we once again have these 7 different columns that we need to analyze. So based upon that, we're going to use our classification model. So what I will do next is I'm going to feed in these unknown observations, and then I'm going to predict whether the unit is occupied or not occupied for line by line. So for every unit, I'm going to make the prediction. This next statement is just to execute for yourself to see whether your code has run successfully. If you haven't done everything correct up to this point, it's going to throw an error and you need to start over again. So this is what I built in order to make sure that you know what is happening. The next thing that we would then need to do is to see, well, now that we've built our model, how accurate is our prediction? And this is the final step of the algorithm. We would like to know that if a particular reading comes in, so we know the temperature in a particular house, we know the humidity, we know the light, we know the CO2, and we know the humidity ratio, could I predict just by looking at the data whether somebody's actually living in that apartment, yes or no? And that is what we're doing when we are actually training and determining the score. So if I run this, you will see that it will automatically test all of those columns against the test set of the occupancy. And the key outcome of this is that I could predict, so our model that we've built with the K-Nearest classification algorithm is 94% accurate. In other words, if I just receive a particular temperature, a particular humidity, a particular light value, CO2 and humidity ratio, no matter from which building that I'm managing, so building that is in the portfolio, I could predict with a 94% accuracy whether somebody's living in the building, yes or no. And for a property management company, this can be of extreme value because, for instance, if they detect that there's a 94% accuracy that somebody's living in the building and nobody is on contract for that building, so there's no lease signed for that building, then that would definitely be a reason why somebody should go and check on the apartment whether there's not unauthorized people living in the building. So here you can see very quickly why this KNN algorithm is so incredibly powerful and how it can help to solve real business problems. Good, this is the demo so far. What I've done for the people who are interested is that they can also keep playing around with this. I've asked a number of questions that we would also answer in a classroom. So these are things that you can start to figure out on your own. And if you're interested in that, you can always contact me for the right answers afterwards. Good, let me take a quick moment to switch back towards the slides and to wrap all of this up. So again, the key point of learning about algorithms, about learning about data analysis, is that you can start seeing how you can predict different elements and different values. And those values, of course, are highly, highly valuable towards companies, because the better you're able to predict that, the more value it will bring to a particular business. And this is one of the key reasons why, in my opinion, you should start learning about data analysis. Good, so this is the lab. I'm pretty sure Estelle is going to send the link with the recording towards everyone who has been signed up for the class today. So in order to wrap things up, because we still want to answer some questions towards the end, my key message is start learning, and start with learning more about what big data can do, how you can help it. And what we've done is that we've provided all of the resources for the enterprise big data for free, available online. So start by downloading the books and reading up on it. And together with APMG, we have launched the certifications. So the first level was launched last year. The enterprise big data analyst level was launched this year. And the exams and the books have been available since the beginning of this year. The certification has been available since May. So obviously, in the tradition of APMG, we have made the training available through accredited training organizations. So besides studying it for yourself, of course, I recommend to go through an official training course where you will learn all of the steps that I've just showcased, but then into further detail. Good. The EBDA certification is quite complex, and that's on purpose because we really wanted to make a deep dive into what does it mean to be a good data analyst. So in this exam, you're going to be questions about all these types of algorithms that I've just shown, and KNN is definitely one of the topics that will come back in the exam. So it's a 2.5-hour exam consisting of 80 questions, and in order to pass, you would need to get 65% correct. It requires some study before you can actually take it, but I promise you that it's worth it because, in my opinion, it will really showcase that you have the skills to do these kinds of data analysis questions. Good, Estelle. I think that I've been already talking again for way too long, and I always get very excited when I get to talk about this. So I saw that a lot of questions came in during the webinar. So can I ask you to moderate some of the questions?
Indeed, Jan-Willem, and it never goes on too long. It's absolutely fascinating. So thank you very much. Right, let's get straight to the questions. Okay, so the first one is in the examples that you use an odd K value. Is there a preference for odd values over even values?
Well, let me first say, from a personal point of view, I always prefer to work with odd values because you can always then have it. There's not really a choice that you need to make. Technically speaking, if you're choosing an even value, you could end up with the situation in which the distances towards the data points is exactly the same. And then you don't have a real accurate tiebreaker. So depending on how the algorithm is programmed, the algorithm is going to need to make a choice if the distances are of equal size. If you're using an odd value of K, that decision is doesn't need to be programmed in the algorithm, because based upon if there's a tie in terms of the distance, it will always choose the one that has the closest proximity towards the other data points. So yeah, that's the answer to the question.
Brilliant, thank you very much. Hope we've answered that one for you. This one is, you've been analysing data from a lot of different sources. How do you deal with data security?
Well, that's actually a very good topic. I didn't really cover that, but if you remember and recall back the enterprise big data analyst slide, so with all of the topics that you would need to know as a data analyst, you saw that at the bottom of that, there were a couple of arrows regarding security, regarding data privacy, and those are definitely things that you would need to manage. So that's also why I'm always advocating for a framework approach towards data, because the data analysis part is not the only part. In order to really get value from data on an enterprise level, you also need to look, for instance, at processes. So you need to look at data security, you need to look at data privacy, you need to look at data governance. So all of these aspects work in sync, and that is always why I'm advocating so much for a framework approach towards enterprise big data.
Great, thank you. And someone's asking, are there any prerequisites? I think you may have covered it, but are there any prerequisites for taking big data analyst?
Yes, the answer is yes. So this course, as you might have seen, is more a bit of a deep dive. So even though people might not have had the background, I hope that I have explained it in enough layman's terms, but there is a prerequisite for analysts, which is the Enterprise Big Data Professional course. So that will, first of all, make you familiar with more common terminology like what I've presented earlier in the slides. What is classification? What is supervised machine learning? So the professional course will give you more of a basic introduction to the wonderful world of big data, whereas the analyst course is really more of a deep dive for people who actually want to learn how to analyze data consistently.
Fantastic, Jan-Willem, and it's worth pointing out again that guidance is free to download from the Big Data Framework website. So anybody that wanted to get started can do that today. That's all the questions that we've had come through for now. But the other thing that I think it might be worth mentioning is that you do have an ambassador program, and so you're building the community within the Big Data Framework. Jan-Willem, so people can contact you if they're interested in becoming an ambassador.
Yeah, absolutely. So thanks for pointing that out, Estelle. Yes, we're currently working with a couple of ambassadors across the globe. So we have a couple in China, and a couple in Europe, and a couple in the US. So we're actively looking to increase that base in order to make sure that there's experts in different regions across the world that would like to be involved with the framework, that would be part of the editorial board, etc. So if you're interested in that, also go look at the Big Data Framework and look at our ambassador program, because I think that is also definitely something for people who want to do this more professionally is definitely worthwhile.
Okay, and just one more question that's just come in now is that in the training, do you cover how to access big data from within your organization?
Yes, we do. So what we cover in the course is basically the whole spectrum of all of the different elements that I showed you on that massive big data analysis process diagram. So all the way from defining the business objectives towards the visualizations. And you've seen that the ingestion of data, which is the second column, includes reading local files, reading files from the internet, but also reading in databases, which is typically where enterprise information is stored. So we will talk about how you can make connections to Oracle databases or Microsoft Azure or AWS in order to extract data from those particular sources in order to analyze it. So yeah, that's a definitely integral part of the whole course.
I think that pretty much wraps it up then, Jan-Willem. So thank you very, very much indeed for your insights and experience. It's so incredibly valuable, this, and very much appreciated. And as you quite rightly pointed out, we will be sending a follow-up email with all of the information, including that URL that you mentioned. A copy of the slides as well, and you're getting a lot of great session and thank yous coming through, so that's lovely. Thank you for the feedback, everybody. That's wonderful, Jan-Willem, and yes, we will do a follow-up webinar with you, and we very much look forward to it in the new year. And so that just leaves us to say happy holiday.
Thank you so much again for hosting, Estelle. It's always been a great pleasure to organize these kinds of sessions. So I hope it has been informative, and look forward to hosting more with you in the next year.
Great. Take care. Bye-bye, everyone.